Hi guys, so today we'll solve exercise 8.1, sixth problem. So it's given that if angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B. Okay, let's first try right angle triangle A, B, C. So here said angle A and angle B are acute angles, this, and C will be our right angle. And also he said that cos A is equal to cos B. This is given. We need to show that angle A is equal to angle B. Okay. So cos A is equal to cos B. What does that mean? Cos A is nothing but adjacent side to angle A, that is AC, divided by hypotenuse, that is AB. Cos B is nothing but adjacent side to angle B, that is BC, divided by hypotenuse, that is AB. So this is LHS and RHS. So if you see this, AB and AB gets cancelled. That implies AC is equal to BC. It means AC is equal to BC. So in an isosceles triangle, angles opposite to equal sides are also equal. This implies angle A is equal to angle B because angles opposite to equal sides are also equal. That's it. Hi guys, so let's solve seventh problem. So it is given cot theta equals 7 by 8 and we have to evaluate these two expressions, like first one is 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus sine cos theta, and the second is cot square theta. So let's do it. So given theta is equal to 7 by 8, the first expression that we need to solve is 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. The second is cot square theta. Okay, so the easiest thing is second one, cot square theta, that is nothing but 7 by 8 whole square. That is 7 square is 7 into 7, that is 49 by 8 into 8, 64. So let's solve the first one, that is 1 plus sine theta into 1 minus sine theta. So this we can do it by two methods. So let's do it in a simple method. So this is of the form a plus b into a minus b. So this, the formula is a square minus b square. So if we multiply 1 plus sine theta into 1 minus sine theta, it will become 1 square minus sine square theta divided by 1 plus cos theta into 1 minus cos theta is nothing but, if you substitute in this formula, we will again get 1 square minus cos square theta. In trigonometry, we have an identity that is called sine square theta plus cos square theta is equal to 1. This we need to remember. This is the formula, sine square theta plus cos square. So now from this formula we can say that sine square theta is equal to 1. If this cos square theta is taken to RHS, it will become minus cos. Similarly, cos square theta is equal to, if we take this sine square theta to other side, 1 minus sine square theta. So now just substitute 1 square minus sine square theta is nothing but cos square theta 1 minus cos square theta is nothing but sin square theta. This we can write as cos theta by sin theta whole square. Cos theta by sin theta is nothing but cot theta. Cot theta whole square is nothing but cot square theta, which again we can substitute 7 by 8 whole square, that is 7 into 7, 49 by 64. This is one method using sin square theta plus cos square theta is equal to 1. The another thing is cot theta is 7 by 8 given. So we need to take right angle triangle. So, so assume this is theta. Cot theta is nothing but adjacent by opposite cot theta. So theta, if this is theta, adjacent would be 7, opposite would be 8. So hypotenuse would be Pythagoras theorem. Hypotenuse square is equal to sum of squares of other two sides of right angle triangle. So this is nothing but 64 plus 49. 9 plus 4, 13. So 113. Hypotenuse is equal to, so hypotenuse is nothing but of 113. So using this, we have to solve this 1 square minus sin square theta divided by 1 minus cos square theta. So now we know hypotenuse. Now sin theta would be opposite by hypotenuse. Cos theta would be adjacent by hypotenuse. So we need to substitute those values in this. So now let's substitute in those values. So 1 minus sin square theta is nothing but 1 minus cos square theta is. So this, if we solve, 1 minus 8 square is 64 divided by root of 113 whole square is nothing but 113. Similarly, 1 minus 7 square is 49. Root of 113 whole square is 113. So now 113 minus 64 divided by 113 divided by, if we are taking LCM here, so 113 will come here. Okay, similarly, so this one and this one will get cancelled. Now 113 minus 64 will give you 49 and 113 minus 49 will give you 64. Okay, 49 by 64, same thing. Okay, these are the two methods that we can solve.
So let's solve eighth problem. If 3 cot A is equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. Okay, let's check that. Given 3 cot A is equal to 4. That means cot A is equal to, if 3 is brought to this side, it will become 4 by 3. So what did he give? 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. We need to prove whether this LHS is equal to RHS. Okay. So cot A is 4 by 3. Now what would be tan A? Exactly reciprocal of this 3 by 4. Okay. So if we draw a right angle triangle A, B, C. If this is your angle, tan A means opposite side, that is this one, by adjacent. So 3 by 4. Opposite to angle A is 3, adjacent is 4. Now we need to find hypotenuse. Hypotenuse square is nothing but sum of squares of other two sides of right angle triangle. So 9 plus 16, that would be 25. So hypotenuse square is 25, implies hypotenuse is equal to 5, because 25 is nothing but 5 into 5. Okay, so hypotenuse we got 5. Now let's substitute these values here. 1 minus tan square A, 1 minus 3 by 4 whole square by 1 plus 3 by 4 whole square. So this we can write as 3 square by 4 square is nothing but 9 by 16. 1 plus 9 by 16. So this is nothing but this 16. If we take LCM and do this, okay, this 16 plus 9 by total 16. Okay, 16 minus 9 is 7. 7 by 16 divided by 16 plus 9 is 25 by 16. So this 16 and this 16 will get cancelled and it will become 7 by 25. This is our LHS. Now let's solve RHS. That is cos square A minus sin square A. What is cos square A? Cos A is adjacent by hypotenuse. Sin A is opposite by hypotenuse. So cos square A is 4 by 5 whole square minus sin square A is 3 by 5 whole square. That is nothing but 16 by 25 minus 9 by 25. So when you have same remainder, you can write 16 minus 9. Okay, 16 minus 9 is 7 by 25. This is RHS. If you see LHS is 7 by 25, RHS is 25. Implies LHS is equal to RHS. That means 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. Let's Hi guys, so let's solve this ninth problem. Given that right angle triangle at B, ABC, if tan A is equal to 1 by root 3, we need to find the values of sin A cos C plus cos A sin C and cos A cos C minus sin A sin C. Okay, let's solve this. Okay, first draw a right angle triangle. Tan A is equal to 1 by root 3. So tan A is nothing but opposite side of angle A by adjacent side of angle A. Okay, tan A is nothing but opposite side of angle A by adjacent side of angle A. Okay, so tan A, what is opposite side of angle A? BC, that is 1. Adjacent side is AB, that is root 3. We need to find AC. AC is nothing but that is hypotenuse. So hypotenuse square is equal to AB square plus BC square. So root 3 square plus 1 square. Root 3 square is nothing but 3 plus 1 square is 1. That is 4. So if hypotenuse square is 4, implies hypotenuse is equal to square root of 4, that is 2.
So we got hypotenuse as 2. From here we can now find out what is sine A. Sine A is opposite side by hypotenuse. Cos A is adjacent side by hypotenuse. Sorry, this is not root 2. Just 1 by 2. Cos A is adjacent side by hypotenuse. Root 3 by 2. Similarly, sine C. Sine C. Opposite side of sine C is root 3 by hypotenuse is 2. Cos C is adjacent side is 1 by 2. Okay, so we got sin A, cos A, sin C, cos C. Now let's solve those equations. The first one is sin A, cos C plus cos A, sin C. Sin A is 1 by 2 into cos C is 1 by 2 plus cos A is root 3 by 2 into sin C is root 3 by 2. 1 into 1 is 1, 2 into 2 is 4 plus root 3 into root 3 is 3, 2 into 2 is 4. Now same reminder, so 1 plus 3, that is 4 by 4, that is nothing but 1. So for first this thing we got 1. Now let's solve second equation. Cos A, cos C, cos A, cos C minus sin A, sin C. What is cos A? Root 3 by 2 into cos A 1 by 2 minus sin A is 1 by 2 into sin C is root 3 by 2. So root 3 into 1 is root 3, 2 into 2 is 4 minus 1 into root 3 is 3, 2 into 2 is 4. So root 3 by 4 minus root 3 is 0. So for this we got 0. Okay. So now let's solve 10th problem. In triangle PQR, right angle at Q. Okay. In triangle in triangle PQR, it is right angle at Q. What did you give? PR plus QR is equal to 25. PR plus QR is equal to 25. And PQ is 5 centimeters. PQ is 5 centimeters. This PQ is 5. PR plus QR is 25 centimeters. Okay. We know that hypotenuse square, that is PR square, is equal to side square, that is PQ square plus QR square. So PR square is equal to 25 plus QR square. Okay. PQ is 5, so I have substituted this 5 here. So 5 square is 25. So now let's bring this QR here, left side. So this is a form A square minus B square. Formula is A plus B into A minus B. So we can write this as PR plus QR into PR minus QR is equal to 25. So PR plus QR is nothing but 25. That is already given. So 25 into QR is equal to 25. So this 25 here it is multiplying. If it goes that side, it will divide. So 25 divided by 25. That is 1. So we got one more equation, that is PR minus QR is equal to 1. The given equation is
PR plus QR is equal to 25. So let's add this. PR plus PR to PR. QR minus QR plus QR is 0. 25 plus 1 is 26. So 2PR is equal to 26 implies PR is equal to, if we take 2 that side, it will divide. 26 by 2 is 13. So PR is 13. So if PR is 13, what will be QR? Obviously 12. Okay, QR is 12. So now we got sides of everything of this right angle triangle. Now we can solve this sin P, cos P and tan P. Okay, what is sin P? Mm, Sin P is nothing but opposite side by hypotenuse. So 12 by 13. Cos P is adjacent side, that is 5 by hypotenuse, that is 13. 5 by 13. Tan P is opposite by adjacent, that is 12 by 5. That's how we solve this sin P, cos P and tan P. Okay.
Hi guys, so today let's solve the problem 11. State whether the following are true or false. Justify your answer. So first one is the value of tan A is always less than 1. Okay, let's take that. If we take a right angle triangle, say A, B, C. So tan A, what did he say? Tan A is always less than 1. Okay, so this is 90 degrees. Okay, this is hypotenuse. Imagine angle A is equal to angle C. If it is 95, this is 45 and this is 45. So tan A would be opposite side BC by adjacent side AB. Okay, since both are equal, so BC would be equal to AB because this is an right angle isosceles triangle. What happens is if BC is equal to AB, that will be equal to 1. So we can contradict this statement tan A is always less than 1 by taking an example of right angled isosceles triangle and prove that tan A is equal to 1, not always less than 1. So the first statement is false. Okay, let's check second problem. Secant A is equal to 12 by 5 for some value of angle A. Okay, now let's check. We'll take a right angle triangle, ignore the curves on triangle. Okay, so secant A. Secant A is nothing but hypotenuse by adjacent side of angle A. Okay, adjacent side of angle A is AB, hypotenuse is AC. So AC by AB. Okay, what did he give? Secant A is 12 by 5. So 12 by 5 is equal to AC by AB. So if we take hypotenuse as 12, this as 5, we need to find out BC. What is BC? So apply Pythagoras theorem. Hypotenuse square is equal to sum of squares of the other two sides of a right angle triangle. So 12 square equal to 5 square plus BC square. So 144 is equal to 25 plus BC square. So BC square would be 144 minus 25. So if we take this plus 25 to the other side, it will become minus. So 144 minus 25 is 14 minus 5 is 9. 3 minus 2 is 1. 1. Okay. BC is equal to root of 119. Okay. This is root of 119. So basic thing that we need to check is the largest side of a right angle triangle should always be hypotenuse. So if root 119 is less than 112, it means this triangle is a valid right angle triangle. So root 119, if we check, it would be between root 100, okay, and root say 121. Root of 121 is 11. Root of 100 is 10. So it will be root of 199 will always be less than 11 and greater than 10. So this is always less than 12. So this right angle triangle is a valid right angle triangle. Hence this statement is true. Next, let's check cos A is the abbreviation used for cosecant of angle A. No, cosecant is different from cosine. A, B, C. Cos A is nothing but cosine, which is nothing but adjacent side of angle A by hypotenuse. Whereas cosecant A is nothing but reciprocal of sine A. Okay, that is nothing but hypotenuse by opposite side of angle A. So this statement is false. Next, fourth one. Cot A is a product of cot and A. Cot A is what is it saying is cot A is the product of cot and A. No, this is false. Cot A means it's a cotangent of angle A. It doesn't mean cot into A. Yeah. If we say A cot A, this means A into cot A. So A into product. But this will does not mean it's a product of cot A. Only left hand side means product. Okay. So this is also false. Next, sin theta is equal to 4 by 3 for some angle theta. Okay. Let's draw the right angle triangle A, B. See, so this is theta. Sin theta is 4 by 3. Sin theta is 4 by 3. What is theta? Sin means opposite side of angle theta divided by hypotenuse. That means 4. 4 is opposite side is AB. Hypotenuse is 3. Okay. So by looking at this, we can say that this triangle is not a proper triangle because in a right angle triangle, hypotenuse is the largest side. So AC should be always greater than AB. AC should always be greater than BC. So it is the largest side. So since 3 is less than this side, it means this triangle cannot be formed and this statement is false. Okay, by this we will complete the exercise 8.1. Thank you.